Okay, I think we're live now. So how you
All
doing,
right,
man?
cool. I'm doing good.
You doing
Nice to
good?
see you.
Yeah. Have you kept up with this MidJourney stuff?
Um, I would say that not specifically, but I'm keeping kind of like a high level, not MidJourney specifically, but definitely keeping like a high level, view of, or at least trying to keep up with many of the different things that are going on. But yeah, I think based on what I've seen, it seems like MidJourney has a lot of very stylized and kind of artistic uh, kind of direction to what they want to do.
Yeah, it's pretty amazing. So it's kind of like stable diffusion, except you can generate four at a time, and you can actually like upscale and also generate variety and stuff. So if you
Mhm.
click like upscale here, it'll actually upscale the image for you, and it does it super quickly. So it's pretty cool. But yeah, so it seems
Wow.
like recently there's been like a lot of this AI art, and it's all seems to be based on diffusion models. Um, so like, why do
I
you think
think
that is?
I think there are some like alternate methods. Like at least Google has like the autoregressive models. I believe that's called like the party model. And recently
Okay,
they had like Muse, which is based on like these like masked autoencoders. But a lot of them are definitely diffusion based for sure.
yeah. I mean, what do you think is the reason why diffusion models are suddenly so popular now?
Well, I think that a lot of it has to do with just the, computational considerations of training a big model using so much data, and having stable kind of easy to understand learning dynamics. And like historically GANs are probably the first big success story in image generation. And GANs are infamously difficult to use because you have two networks and they're kind of interacting with each other, and there's lots of kind of pathological instabilities that can occur, like mode collapse, or one network collapses causes the other to collapse. And a lot of that is just kind of due to the nature of the loss function that's being compete with each other and try to fool the other one or try to understand what the other one is doing. And I guess it's just that that kind of training framework is just not very stable.
Okay.
Although recently, I think like the NVIDIA group did just train a text to image GAN model. So, in kind of probably in the next few years, we're going to see that, there's probably nothing so special about diffusion models, at least from the text to image kind of side of things. I think a lot of what is done initially by diffusion models can be done with autoregressive models, like has already been shown, or with GAN models. But, diffusion models, one of the nice things is they have this like mean square error loss. So
Okay.
really, when you're training the models, oh, sorry, go ahead. I can go on
Yeah,
for more.
let's yeah, we'll get to all that. Sounds like you know what you're
Okay.
talking about. So why don't you just give like a super brief introduction and for yourself so people know who you are and why you're qualified to talk about this? Because I think you're very uniquely qualified to talk about, these AI art models that are mostly diffusion based coming out right now.
Yeah, sure. I would love to kind of just say what my experience is. So got kind of involved with deep learning and image generation when I was like a PhD at UCLA. And I worked with Professor Songchun Zhu, who is, a very well-established and well-known like vision researcher from the years before deep learning, when, kind of a lot of these image-based statistical analysis and things like that were very difficult to do, and were very cutting edge. But the methodology also, and the computers hadn't really been developed for what we see today. But yeah, so then I got involved with his research group, and he had some work from the 90s, which is trying to do things like texture synthesis. So before we kind of generated whole images, people were usually trying to generate things like textures on images. And that was done in kind of what's in the world of statistics is called like maximum likelihood, which is, kind of one of the most fundamental statistical learning methods. And his his method in the 90s is based on like what's called like an energy model. So an energy model is trying to learn kind of like a surface, so that the surface will say where likely states are distributed and what we call like the image space. And yeah, so he kind of worked on that direction in the late 90s. And then when I first started getting involved was probably around 2015, 2016, which was when GANs were very, very popular. But GANs were achieving a lot of their early breakthroughs, but there's definitely this recognition that maybe other learning objectives might be easier to work with, because GANs don't use this maximum likelihood objective, which is kind of one of the main objectives that
Okay,
comes
so
from
like,
statistics.
yeah, maybe not too technical, because I don't think my
Sorry.
audience necessarily has the same background as you. But you've done a lot of generative modeling, which when it comes to deep learning, basically, generating images, right? Specifically from noise. So basically generating images out of thin air that look realistic. Um,
Yeah.
and so,
And then
yeah,
maybe I'll just give like a less technical kind of wrap up to that. So like,
yeah.
yeah, I think I got involved at a time when people were kind of moving away from GANs towards like a more probabilistic kind of approach. And I actually did write a paper like in 2018, 2019 of basically starting from noise and using these kind of gradient trajectories to go from noise to images. And that kind of, although it's not done by diffusion models in exactly the same way, that kind of approach caught on, and other people were kind of thinking in a similar direction. And eventually these more probabilistic methods eventually led to the diffusion models, which are what is very popular today. So sorry for kind of going off the rails
Yeah.
sometimes.
I think your video,
Let me know if
it looks like your video is frozen, by the way. Hold on, let me try removing and then adding you again. Okay, now it's just dark. That's okay. Do you have like bad internet connection where you're at right now?
it seems fine. Let me leave and rejoin.
Okay, I got you. But yeah, so I've been playing around with these MidJourney models, and then right here you have this bot. Basically, people can enter whatever they want. Like here, this guy's generating random images. You can also specify like you want a specific style for your art. Like right here, looks like a rich man driving a Ferrari while getting on a private yacht in Dubai, waiting for his golden private jet. So there's some that also ask for like specific style. Like if you specifically, like right here, I had this generating in the style Monet, who's an impressionist painting. So it's pretty impressive stuff, what they're able to do. Hey, Mitch.
Can you hear me now?
Yeah, I can hear you. Looks like you're back.
You see me? Okay, great. Yeah, so
Yeah,
if I'm kind of going off, let me know.
Yeah, but just so people know, like you actually know what you're talking about. You're not just someone who read a couple, of AI articles on BuzzFeed. Like you actually have a lot of expertise in this area. So as far as I remember, yeah. So as far as I remember, like the first exposure that I had to AI art that I remember was this style transfer stuff. Do you remember the stuff?
Yeah.
This neural style transfer.
This is kind of, I think, also the beginning of this direction for sure.
Yeah. So basically, you can have two images, right? You have one image that is the content, like a turtle, and then you have another image that is a style. So here, this is like some Japanese drawing, and then basically they were able to merge these two things together, and then generate something that looks like this. So as far as I remember, like for the AI art stuff becoming mainstream, this was the first paper where that happened.
Yeah, and this kind of thing is very related to kind of what my professor was working on, where you can treat it more as like a texture kind of problem, right? So this is really trying to match basically what we call like the low level statistics, or kind of the local statistics. So if you kind of look at any small piece, that will match on average what any small piece of the target image would look like. So yeah, I think that this is definitely like could be understood as a sort of textural manipulation of the image.
Okay. And then after this, it was generative adversarial networks, right? GANs that you were talking about. So I'm just trying to see like how we got to diffusion models. As far as I remember, you had stuff like this. You had GANs, and what basically a GAN is you have two neural networks. So you have two models that are competing with each other. One model tries to generate an image that looks real, and the other model tries to determine how real that image looks. And then hopefully, if you train it for long enough, the model is going to get really good at generating real images. So that was going on for a while. And then somehow it made it from the transition from these GAN models to the diffusion models. So do you have like any insight on, like why did that happen? Like why did we go from GANs to diffusion models, which is what, all these open source AAR platforms are using now?
Yeah, I think that definitely my research is part of this, transition away from GANs towards other things, and that's kind of the time when I first got involved and first had kind of some of my, research success stories and stuff like that. So, the GANs, like I kind of mentioned, and like you mentioned, are this adversarial objective, and this is a very, I guess, different objective than is typically used in statistical learning. So in statistics, the most common way to learn something is learn like a probability distribution. So even though it sounds boring, like it's actually a very, very powerful idea of it's instead of learning maybe like a normal distribution, which you guys might have heard from like your like college stats classes or something, you can just learn a distribution of anything you see. So we treat observe data as just points that we observe from a big distribution, and we want to model that kind of distribution. That's kind of the classic statistic way to approach kind of image modeling and generation. The GANs have these two networks where they're sort of competing with each other, so it's just not really as well understood, and it's more of a recent kind of development. And then since GANs were working pretty well but unstable, people wanted to go to more kinds of classical probabilistic objectives, but we didn't really have the tools to do that. And to kind of not go too deep, there's this issue known as like the normalizing constant. So that's the big issue of using probability models, where it's hard to basically make them sum up to one, because probabilities have to sum up to one. But so I kind of worked on one way of dealing with the normalizing constant, which is like called the energy model. Another way is more like the VAE model, which is dealing with the issues of probabilistic modeling by making everything related to like a Gaussian or a normal distribution. And that works very well because Gaussians have very nice loss functions. And I think diffusion models can be viewed essentially as a variation of the variational autoencoder, where you're basically connecting many Gaussian distributions together, or normal distributions, just like you might have learned in Stats 101.
Okay. So like why do you think because I'm looking at this MidJourney bot, and what's actually amazing about this is the fact that it can do it so quickly. So is that just like an engineering problem where basically the GPUs are better than ever, and now they can essentially, you can type something in, they can run it on their server super quickly and then get it right back to you, where that was impossible a couple of years ago, where it would have taken a lot longer.
Yeah, like the diffusion models are pretty slow among all the generative models because they have, this step-by-step process going from noise to the image. I don't want to say too much specifically about how MidJourney works, because honestly, I don't know. But there's definitely been a whole ton of research to accelerate this sampling process. So there's many different sampling methods, some of which can be faster. There's also ways to kind of distill the sampling paths. So instead of taking maybe 1,000 steps, you can take 4 steps that count for 250 steps each, or something along those lines. And also just engineering and having good GPU servers and that kind of thing too. I honestly don't know exactly what tricks that MidJourney specifically is using.
Do you think part of it is also just that there's so much more data that's available now? I think I was like reading some article where there's some rule, right, where the compute increases by 100% every couple of years or so. Do you remember how many years was that? What was that? It was like some law. I
Yeah,
forgot what it
like
was called.
yeah, that's called like Moore's law. Yeah, so like I've read that like there is a separate Moore's law for like deep learning, basically, where I think it's actually 6 months. I don't know if this is true or not, but I've
Mhm.
heard that I don't know 100%, but I think I read that every 6 months someone essentially uses twice as much power to train a model, basically. So like if you're looking at, what is the previous biggest model trained, it will only take 6 months for someone to basically double that model in terms of either the parameters or the amount of compute or something along those lines.
Okay, so the
I do
models
think that
become twice as big. You're saying like they become twice as big, these mathematical models every 6 months.
something along those lines. I might be kind of making stuff up here, but I
Okay.
believe there's essentially like what you're calling Moore's law is kind of very long kind of like process since the early days of computing, but I believe there's like a second version which is which is in this new deep learning era, which is even more rapid, basically.
Okay. Do you think these models get twice as good when they become twice as big? Or is there some kind of like exponential decline? Like there's some kind of what is it? Law of return, diminishing returns, where these models are
Yeah,
getting
yeah,
bigger and bigger, but they're not actually getting that much better.
yeah. That's a question definitely on many people's minds, and that's called like scaling laws. It's a very active research area, and people basically want to know, the kind of questions are, compute power, number of parameters, and amount of data, right? Those are the three big things. And what it seems like now is that data is actually the bottleneck. So making the models bigger will not be nearly as effective as training the models with more and possibly much higher quality data. And that was actually just discovered last year by DeepMind and in their like chinchilla paper, where essentially they trained a much smaller model using much more data that beat this much bigger model trained with much less data. So if we could get more data, we would, yeah, we would. That's what people believe is the most promising direction.
But right now, basically, they're just web scraping Google, right? Is that how it works? Like the Layon data set, for example. Are these data sets basically made just by going through Google searches and then collecting all the images that match?
I think that's generally the idea. Yeah, I don't know exactly too much about these, like the details of assembling these massive data sets, but yeah, I think they're basically just kind of, crawling through as many web pages as they can. And I think, again, I don't know exactly if this is right, but I believe that it's just a default web format where images are kind of paired with text, kind of in the HTML sort of code that accompanies the web page. So it's very easy to kind of search for these pairs. And just because that's a web format has allowed people to generate these data sets, which, is very unique, especially for images and text, which is why, other kinds of breakthroughs like video and text are going to be more difficult because the data collection process is going to be is more tricky.
Okay, I see. And then how much of it is also natural language processing breakthroughs? So I know all of these models, they have some kind of processing, right? Because you enter the text prompt, it generates images, but then there's something in there in between that's going to process the text to the image. And I think all of these use something called clip, right, or something similar to clip, which is kind of this
Yeah, yeah,
new
yeah. Clip
language processing
yeah,
model.
exactly. Yeah,
Okay.
so yeah, that's a really good point. That's the whole other side of this breakthrough, and that's the side that I don't have as much kind of hands-on experience with, because I don't do like language as much. I come more from the vision side, um, but like in the language side, the huge breakthrough is these like transformer models, which I'm sure you Tao have definitely heard of,
Hmm.
right?
Hmm.
And clip being an example of a transformer. So basically what the transformer does is it takes natural language, which is just something you type out, on your computer or on your phone, or you just say in normal words, so just raw text, and it can make like a vector. So it'll take what just a normal statement and make a vector out of that statement. And somehow this vector, which is just a list of, say, 750 numbers that represents the word itself. And yeah, like this is usually trained by these very large pre-training algorithms. So one way to do it is CLIP, which is basically CLIP will. I don't want to go too much into the details,
Yeah.
but it
So
will take a sentence.
basically what you're saying is all of these text prompts, basically these text prompts go into the model and they generate a bunch of numbers out of them. And then those numbers are added with more numbers that are extracted from the images. Or those numbers
Exactly.
are basically processed, and then these images, they can get these images. And so this is all possible because of like these gigantic new data sets that are coming out. Is there any like boundaries on collecting images for this data set? Like, so for example, can you just go to Google and type in image of a person or image of a girl, image of a boy, and then just take all of those images, put them into your data set? Or do they actually, in general, like limit these things? Do they have like any, like regulations for this kind of stuff?
We're gonna see that very, very soon. Have you heard
Okay.
about the Getty lawsuit?
The Getty lawsuit? No, I haven't heard about that.
Getty is suing Stable Diffusion right now, actually. So they
They're
basically,
suing Stable Diffusion. Hold on, let me
yes,
pull that
yes,
up. The Getty lawsuit.
yes,
Okay,
yes.
interesting.
You can probably just see it if you look up Getty sues Stable Diffusion. Um,
Oh wow.
yeah, yep, there you go.
Is suing
So
the
basically,
creators of AI art tool Stable Diffusion for scraping its content. Interesting.
so basically, like there's just over the past 2 months, there was a bunch of research about like what's called like membership inference. So can I determine if a model was used to train Stable Diffusion? Or also, will Stable Diffusion exactly reproduce images from its training set? And the answer to both questions is yes, you can determine if an image was used to train the model, and yes, it will make nearly exact replicas of certain images from its training set. Like, I think this is what you're seeing.
Wait, are you serious? So, like, for example, for this MidJourney model, for example, you could take like an image on the internet and then check to see if that image was used in the training of the model. You're saying that's possible?
If the model was open source, I don't believe MidJourney is, so you can't do it without the weights. But if you have the weights, you definitely can do it.
Like, wait, okay, that's kind of a well, that's kind of a big deal then, because I think one of the big things going on with artists, for example, is that they feel like these models are using their IP without like telling the artist or giving them credit. But you're saying it's actually possible to go inside the models and check if those specific images were used to train the models.
I don't know if it's 100% foolproof, but definitely you can find, millions of images that you can verify
Yeah.
were used to train the model.
How does that work exactly?
I would have to look at the details again. I think they just have some sort of I can't quite remember. I think a lot of this is headed by one of the researchers who is very famous for like adversarial attacks,
Mhm.
which is another hot topic of the deep learning, where it's about trying to trick or otherwise find strange behaviors of these models. So I can't remember exactly how that's done, but they def oh I think they along the line I think one way is you can look for images that are used over and over again, because
Mhm.
since the training data set is so large, some images are used many times. Like one example is like you might have seen this girl of the picture of the Afghan girl with the green eyes. It's like a
Yeah,
very
yeah, yeah.
famous
What's the
picture.
okay, hold on. I remember this. This was like huge in National Geographic, right? And then so
Right,
yeah, so this girl,
right.
they took a picture of her and then she was super young, I think like 20 years old or maybe even less than that. And then later
Mhm.
on they went back like 2 years later and it looks like she aged 10 years. So I remember that was a yeah, I definitely remember this. So you're saying
Yeah, but basically, her face appeared so many times in the training data that the model essentially can exactly reproduce this exact image, because it was and this happens, for the even the very small ones that I've trained, or moderate scale ones. If you have the same image repeated, say 4 or 5 times, it can the model indeed can make almost exact replicas of certain repeated images. So I think one way is just look at images that are repeated a lot, and then they had some way of finding that the model would make these repeated images. Maybe even just using the same caption or something.
Okay,
There's probably other
interesting.
ways to do it. I
Okay,
think
so
you can
actually,
look at like our inference attack.
yeah. No, I actually want to talk about that actually. So do you know an artist called SamDoesArts?
I do not know.
Okay, so this guy is like the #1 Instagram artist right now. So this is his
Oh,
style specifically. He has 2 million followers. He has a YouTube channel. He's
mhm.
extremely popular, and he has a
He's very
very
popular.
distinctive style. So you can see all of his images kind of have a similar style. He specifically draws this one girl character. And so there was someone who used one of the AI art models, trained it on his images, and then started replicating versions of like Sam does art style. So let me find that actually.
Oh wow.
Uh, and then basically his contention was that they unfairly used his art to train this model. So you can see that like this is kind of what the model is able to produce, and it looks very, very
Mhm.
similar to his art
Yes.
style. So do you think, like you were saying before, it's actually possible for them to be able to look at the images produced by the model, and then look at the images um, used or the images produced by Sam Does Arts, and then come to the conclusion that the model was actually trained on his art specifically?
I mean, like from a kind of like computer science forensics thing, I think you would need
Yeah.
probably the model itself, but definitely
Okay.
with the model and some example images of the source data, you probably could. Yeah.
Okay, that's huge actually. I didn't know you could do that because I know these models are trained on, millions and millions and millions of images. And in some way they kind of average over the images, right? That they're trained on.
Yeah, yeah.
Um, but the fact
But
that you could
somehow also
actually,
they can use some sort of digital footprint or kind of identity inside the model weights. It seems like.
okay, that's pretty cool. Um, all right, I could see that definitely being used in the future. Like, I'm sure there's going to be a lot of lawsuits, more lawsuits coming up. Like you were saying
Yeah,
with the
for sure.
Getty Images lawsuits, where people are suing these companies, and then maybe we get a hold of their models and then actually see what images their models are trained on. Um,
Yeah, yeah.
yeah, but
There's
I'm
there's so many angles of that. It's so hard to know kind of what the right path is, I guess.
yeah. But on a side note, have you seen all the Chat-GPT stuff that's going on? Like Microsoft
Oh yeah,
acquired
of course.
Chat-GPT and they want to use it for bin search.
Mhm, mhm. I
Yeah,
believe they also have Dolly image generation is either gonna be or already is part of the search too, right?
of Bing search.
Like
Wait, I have to look this up. So Dolly is
I think they both
used.
have ChatGPT as well as the Dolly 2 image generator model.
Wow. Okay, so
Everything's
what
moving
is?
so quickly, it's impossible to keep up.
Okay, so how does this work? So basically, in Bing, you can type in like a specific image that you want, and then it'll produce it exactly like using Dolly.
Yeah, and Dolly is probably a step above Stable Diffusion even today.
You think so?
I don't know. I don't want to get into like I don't want to maybe
Yeah.
make the someone upset, but
But
that was my impression.
did you see how Google tried to do the same thing? Like Google formally announced that they're also going to integrate their own natural language model called Bard into their
Mhm, mhm.
search engine, and then it kind of flopped, right? Because they produced some results that were apparently fake.
Yeah, I saw that like unfortunate live demo. I honestly
Yeah,
I think that it was kind of just bad luck, I guess. They probably should have prepared a little more, but my feeling is that Google's product is very likely very similar to ChatGPT. Maybe a little better, a little worse, but um, Yeah, I mean, like, I imagine all of these big tech companies, they have these things behind closed doors, and
Hmm.
and it's kind of like, like when they make movies and like one kind of movie will come out, like maybe it's like a pirate movie, and then like another studio will release like a pirate movie too. Like, it's,
Hmm.
if like, because like it's the same thing for like the tech companies. Like, if one person moves, the other person will have to respond. And because like as soon as as OpenAI released DALL-E 2 last year, like 2 months later, Google released Imagen, which makes me think they must have had it like before that time, and they're just kind of waiting for the right time to
Yeah.
release it.
What do you think, like for Google, for instance? So they have the stuff that they've released, right? But for the stuff that they haven't released, um, what do you think like their capabilities actually are for, the most state of the art models that they have in house?
I don't know. That's a really good question. I would say that it's hard to say, but I would imagine that it's probably better, but not fundamentally different than what you can kind of access either via Chat-GPT or Stable Diffusion. But I don't know. Maybe they have something completely amazing that no one's seen before. But I mean, like, research is good in some sense because it encourages them to eventually push things out, right? Because say they have something amazing that they're not sharing. Well, if another company or another group comes out with that thing, they publish it, they put it on, the site first, they get credit for it, even if Google had it for like 3 years. So I think AI research is actually quite open relative to maybe other areas of science where um, it's hard to maybe get the source code. AI research, at least right now, kind of the pressure of the pace and the importance of gaining credit for these inventions actually is deterring people from maybe putting certain things behind closed doors for too long. But who knows? Maybe there is some really secret stuff.
Yeah. Okay. Yeah, I did want to talk a little bit more about, the impact of this specifically on AI art. So nowadays you're seeing these models come out, and for a while people weren't as worried about them because they didn't seem as customizable. So you could say like generate an image of a dog, but you couldn't really specifically customize it to your needs. So like let's say you're writing a children's book and you need illustrations, right? Well, maybe a year ago, you wouldn't have been able to specifically generate the illustrations that you want for that book. But it looks like nowadays that's becoming more and more possible. Like, what do you think the level of customizability is going to be, in a year from now or 2 years from now? Like, let's say, they had this image and you said, I want to make her eyes a different color. Would that be possible?
Yes, for sure. Definitely making the eyes a different color. I think that is already possible, perhaps. Um,
Okay.
Maybe making. I mean, I've seen. And I know for a fact that you've also worked on some of these like dream booth kinds of things that
Yeah.
are customizing and personalizing these models to specific user defined needs. So yeah, like that technology is very rapidly emerging, and I expect probably in a year or so you'll be able to probably get a consistent character and be able to have consistent settings and yeah, probably to be able to make storybooks. And you probably could already, if you're clever and had a lot of time and really worked at it, I think and I have seen some things that look pretty reasonable that people have already put together.
Okay, I see. So then, I mean, do you think there's anything that the AI is going to be able to do that like artists won't be able to do then? I mean, that our AI won't be able to do that artists are going to be able to do? Because before, for a long time, it was customizability, right? Like you could specifically ask an artist to generate an image that fits your needs exactly. But now it looks like the AI is going to be able to do that very, very soon. I mean, is there like what are the limitations actually for what the AI is going to be able to produce?
That's a really good question. And I mean, I think composition and what is in the prompt is still human, I suppose, right? Like
Mhm.
it like actually, making a story is definitely like way more than just making like one cool image, right? Like I I in terms of the artistic components, I I don't know. It's hard to say whether I still think that a person probably could make it more personalized, and like the kind of like working feedback loop right now is probably significantly better for a person. It's hard to say eventually what the quality would be, but I mean, there's still like the issue of like style and things like that, right? Because even now to say, what is the style of the image, the easiest way is to say like someone's name, right? So like you mentioned, like the SamDoesArt, I believe is his name, right? You could say like this blah 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 picture in the style of SamDoesArt, but the issue is that you're using that person's name to access that person's style. So then where is the style coming from? It's coming from that person, right? So whether or not it can kind of make new styles or that kind of thing, or whether it can do anything that's not essentially what you could call like an interpolation of things that already exist. Can it like stake out new territory? Probably eventually, but I don't know. I I don't. It's going to be really interesting to see, and like I also do feel that artists should have some way to consent to have their work either not used or used, but it's hard to know exactly how that would be practically implemented.
Okay,
Right now,
but
like no one ever saw no one could consent or not consent, right?
Yeah, exactly. Yeah, that's the thing, right? Because if your stuff is on the internet, it's probably already being used to train some of these models. But yeah, like you were
Almost
saying
certainly,
earlier, yeah, how like you could actually, if you could actually get your hands on these models, you would be able to detect whether or not the image that you made was actually used to train these models. I could see that definitely being something that comes up in the future. When
yeah.
these companies get sued or things like that.
Yeah, like a really interesting exercise would be like, what if you could train Stable Diffusion with everyone's art in the world except SamDoesArt's art, right? How
Right,
close
right.
can you actually get to his style with everything except his art, right? I think that kind of question is kind of related to, can it really do, arbitrary styles or new styles, or is it, kind of copying or mimicking things? My guess is that it probably could, or, like maybe it had never seen like a Renaissance painting, right? Like if you train it on every picture ever except, like Monet's like water lilies and the Van Gogh things, which have,
Mhm.
a kind of unique style, can everything else that's ever been made that's not this style recreate this style? Like I think that's the kind of question that is maybe reveal what it learned about creativity in a general sense beyond just memorization, I guess.
Okay, so you're saying it's likely that if you train this model on all the Instagram artists except for Sam Does Arts, it wouldn't be able to replicate Sam Does Art style. It would
I
only
don't
be
know.
able to
I
get
don't know. I think to
okay.
some extent it could, but I don't think it could get nearly as close as it could unless it specifically had his data. But I don't know.
Yeah,
Honestly, that's a question that is really hard to answer.
yeah, yeah. I mean, because
Because you could
I'm
say
looking
there's
at these
very
images.
oh, sorry.
Sorry, what was that? I think you got cut off for a bit.
I was just going to say, because you could say that it's very likely that maybe there's 5 people on Instagram who are similar, and if you average what they do, maybe it could reproduce what he does. But how do you get that out of a text prompt and things like that? It is hard to say. So
Okay, I
yeah,
see.
I think that kind of personality and individual style and things like that are still there's still very much a need for that, because in order to make something, there has to be that thing in the first place. Maybe someday AI will kind of close the loop and make new styles, but it's hard to know what that would be like, I guess.
Okay, I see. By the way, have you also kept up with the deep fake stuff? Like, remember a couple years ago, they had a deep fake of Obama, right? But you could tell it kind of wasn't real. But recently there was like a deep fake of Morgan Freeman. Do you remember seeing that?
I did not see that. Can you just share the video
Yeah, let
for a
me pull
second?
that up. It's actually incredible because it looks exactly like Morgan Freeman. I'll pull that up for you. But yeah, but are you familiar with that kind of work in general? The deep fake
Not
stuff?
as familiar. There definitely is overlap, but kind of like face modeling is a very kind of specific subfield of generative modeling, and there's a lot of very well developed techniques for faces specifically that I'm not too up to date with all that stuff.
Okay, hold on. I have to pull this up somehow. Wait, that stuff is kind of concerning, right? Because it's basically impossible to tell the difference for a human, at least.
Mm-hmm.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What
Is that his voice?
Quality?
Yeah, no, this is the AI's voice. That's
this also AI generated voice.
This is completely AI generated. Yeah, I was looking at this video, and the one thing that I could see looked slightly fake was the way that he blinks. But everything else
is it the ability to
real.
capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real?
So what do you think? What are your thoughts on that?
It's very, very impressive. And yeah, I mean, we're not going to be able to trust video as a source of ground truth information like in the future. And we're just going to have to accept that, I suppose.
Okay. But like, so say that these... So like, let's say that these models for humans like me and you are basically indistinguishable. Like we look at this and we think this is definitely Morgan Freeman, right? But like, would you be able to train like some kind of a model that's able to distinguish between whether this is fake or not as the generation gets better and better?
I believe that currently, yeah, I think like another AI very likely could detect that this was an AI.
Very likely.
At least I would say at right now, very, very likely. Maybe in many years, like 5 to 10 years, it'll probably be harder. But yeah, I mean, the AIs are really, really good at these just imperceptible features and these pixel level things. And, you know, like if there's only a very small border of his face that is, you know, suspicious, it can actually, you know, very, very effectively hone in on those, you know, tiny little imperfections and those invisible features. There's definitely a lot of invisible features that computers are using, and even in normal image detectors that a person doesn't use. And that's actually why there's like this adversarial examples and those kinds of things.
Okay, I see. Okay, so I have a prediction to make. I would say that by 2023, I would say that 50% of all of the top content creators on the internet are going to be basically 100% AI based. Like maybe you have a person somewhere in the background.
You mean 2033?
By 2030. By 2030, I think.
Okay, 2033. Okay. Wow. Yeah, I think so too. I mean, for things like comics and stuff like that, you know, like it could really enable a lot of people to do all sorts of really cool things that, you know, you couldn't do just because of the issues with, you know, like actually making, you know, like pictures that look good. But like how do you feel about all this as like, you know, like as an artist yourself, I suppose?
Yeah, I mean, I don't know how to feel about it. I mean, I think there was a clip of Gary Vee. Do you know Gary Vee?
No, I don't.
Gary Vee. He's kind of like this, you know, entrepreneur, self-help, life guru type guy who posts a lot of TikToks and videos and things like that. And he was saying that these AI models can kind of abstract away the boring stuff and let you really do the creative things. So, for example, you think of an idea, but normally you would have to write out an entire script. But now you could tell Chat-GPT to write the script for you, and you just, you know, revise it at the end. So what he was saying was, basically these AI models can abstract away all of the stuff that's kind of tedious and just leave all of the creativity, like only, you know, the idea generation up to the people, for example. So like for, you know, art, for example, right? Like all of these prompts are still created by humans to generate the images. But I do think at some point you'll be able to create some AI that knows people's preferences, right? So for example, it looks at your Instagram history or YouTube history. It knows what you're interested in. And instead of having a recommendation like YouTube that recommends other videos for you, it'll actually generate videos for you. Or instead of Instagram recommending other images to your feed, it'll just generate images to your feed. What do you think about that?
Yeah. That sounds like a really like cool sci-fi idea. It might become
Yeah.
reality. Yeah, it's so hard to say. Like, will we be living in these like AI generated like dreamscapes? But like, forget reality and things like that. I don't know.
Yeah.
It's
Do you think that's kind of dystopian? I feel like it's a little creepy. I mean, but I do think it's coming though. I think at some point, Facebook, Instagram, YouTube, like they will start recommending you AI generated content for sure.
yeah. I mean, as like a video game enthusiast, I definitely can see the potential for having much better like NPCs and stuff. Like when you play a game, sometimes you can see where like the team must have been just so exhausted they just can't finish
Yeah.
this part, or like
Okay.
like there's some textures that don't seem good, and like the AI could really spruce all that up and add a lot more depth and stuff. So I definitely it's not all bad, but as someone who like also I don't do like visual art, but I like to play my guitar, and I definitely know that like a lot of the artistic experience is being in the moment and like trying to figure out how you want to say something or how you want to play something, and like saying that all the creativity is just at the high level, I don't agree with. A lot of the creativity is those low level decisions as well, and it's just kind of the nature to always be moving away from low level to high level. The same thing happened with computer languages. Like there's probably a million ways of doing low level coding in beautiful, awesome ways that we just would never know about now. So, I think there'll always be the potential for you to be able to exercise your creativity, and sometimes just certain ways of exercising your creativity just vanish with time.
Okay. What video games are you playing right now, by the way?
Like Fire Emblem for the Switch.
Fire Emblem. Okay, wait. I want to see if is Fire Emblem a type of game where you can have an AI replace it? It must be, right?
Yeah, it could be like your like opponents like on the battlefield, basically. Like it's like a strategy game. Yeah, like definitely better AI opponents and stuff. There you go.
Okay, I see. Yeah, this game, I remember Fire Emblem. All my friends were playing this a long time ago.
Oh
Let's
yeah.
see, in high school. But it's one of those games where they never changed the graphics, right? But it's just kind of nostalgic like that, where people still like playing it, even though it still has the old
Yeah,
graphics.
the graphics haven't changed that much, and even the main gameplay mechanics have not changed. This is a really old one. I played this one when I was much younger.
Okay,
This was a
I
fun.
see. Okay, I see. All right. Well, thanks for coming on, man. I think that about wraps it up. But appreciate you coming on and talking. And do you have any closing thoughts in general about the direction that this research is going, and the impact it's going to have?
Well, I would just say that even kind of the researchers have no idea what's going to happen more than the general public does, I suppose. And
Okay.
as someone who's been doing generative modeling for probably 6 or 7 years, I am completely blindsided by everything that's happened in the past like 1 to 2 years.
Really?
It's really, I never thought this day would come, and it's really cool that it did, and I wonder what will happen next.
Is it advancing faster or slower than you would expect?
Probably faster. Yeah, I would say much
Really?
much faster. Yeah,
Okay.
I mean
Yeah.
the big surprising thing is that the language models, at least to me, is that the language model kind of encoding vectors literally describe what the sentence says. Like they actually have essentially full semantic information about the entities and their compositional relations and all these kinds of things. So yeah, I mean, and then just the fact that you can just plug these in with generative models, like the language model says what is in there, the generative model decodes it into something that matches the description. Like that is, it's actually very simple how it works, but just the fact that it does work is very, very surprising to me still.
Okay. I see. Yeah, I mean the last frontier really now is video, right? That's still the one thing that seems to be very hard to solve. Like you can generate video sequences of 10 seconds, but anything beyond that is still very difficult.
Yeah, yeah, yeah. Definitely, like, a lot of the challenges are computational because, if
Mhm.
images are so expensive and videos are essentially many images, it's even more expensive and, we're used to very, high frame rates and stuff. So that's a huge challenge, and also the data, right? Like, just the fact that it's hard to get video and it's relatively easy to get, like, videos and captions, but actually videos and descriptions what's in the video is a little tougher because the captions
Mhm.
might not actually describe, like, the content of the video necessarily.
Okay, I see. Yeah, and I mean another thing that kind of bothers me a little bit is I listen to all these interviews of people talking about these AI models, and the thought seems to be that if you just throw data at it, that'll basically solve the problem, right? Like,
Mhm,
China has, so much more data than we do, so they're gonna win the AI race.
mhm.
And I I don't know. I feel like there's a little more to it than just the amount of data that you can acquire, um, and uh, and the size of the models and the size of the GPUs that you have. I think that there's actually a little more thought that goes into it. Um, I don't know. What are your thoughts on that? Do you feel that like in general, it really is just a function of the amount of computational power that you have and the amount of data that you have?
That's probably one of the most important questions right now, and when I think about that, I kind of go back to things like self-driving cars, which
Mhm.
is kind of the opposite of AI generation, where it's something that we thought would be relatively easy, but even though it's been around for almost a decade now,
Exactly.
there's not that much good progress. So it's very strange that, it's so much easier to make these amazing images than to, teach a car to drive. And it, for,
Are you being
from
sarcastic? I can't tell if you're being sarcastic or not. Because intuitively, I feel like driving a car is more challenging. I got a speeding ticket last night, actually.
Okay, okay.
Yeah, I
Well,
was
like I
quite
can't draw, I
embarrassed.
can't draw for anything, but I can drive a car. So maybe like like it takes years of practice to learn to paint, but it only takes like a few months to learn to drive a car, right?
Mhm.
I don't know. Maybe it's not. Maybe it's not harder.
Okay, okay. But you do think that there's a little more thought that goes into actually designing these models,
Yeah, yeah,
like
because
this.
like the thing about AI is it works great for data that's in distribution. That means it's similar to the data it was trained on. It works badly for out of distribution. And
Mhm.
the thing about scaling is if you have enough data, everything becomes in distribution, right? If you scan the whole internet, essentially you can't really say anything that it hasn't already seen. So these massively scaled AIs solve that out of distribution problem by making everything in distribution. But for driving, you could never hope to encounter every, say, driving safety critical scenario, right? And
Mhm.
so, you know, I think that there probably is going to have to be maybe some other advancements of maybe more like abstract reasoning and things like that, right? Because right now the AIs can do kind of two things. One, they can make what the training data has, and two, we can fine tune them to make what people like, right?
Mhm.
Like chat, like the GPT-3 that replicates the training data. Chat-GPT on top of that, it replicates the training data and makes whatever the trainers say they like or that they tell it to me.
Mhm.
But it still isn't really knowing about the world itself, right? Like it doesn't know kind of consequences and like it doesn't know how counterfactuals. It can like act in one way and see if I do this, then this happens. If I do this, then this doesn't happen. And I feel like
Mhm.
those kinds of things are probably not solvable by scale, but maybe they are. I think that's it. No one really knows, I would say.
Yeah. Do you know, by the way, that like for recommendation systems like YouTube and Instagram or Facebook, for example, is that done through reinforcement learning? Because I think that would make sense to me.
I don't really know too much about that. It's another very big area, but
Okay.
probably yeah. I think that if they're not using it now, I'm sure someone has tried in the past.
Okay. All right. Thanks. I'm just curious because I really do think that it's going to get to a point where like all of these social media websites, instead of recommending you people, are going to recommend you, some AI generated content within like 5 years or so, I would say.
That's a really
Right.
cool prediction, and you should ask Chat-GPT to write you a story about it, I suppose.
Yeah. But no, really think about it, right? Imagine you go to YouTube and you type in like, what do you like to watch? Like cats? That's
Yeah, sure.
you have a couple of cats in the house, right? So you say, I would
Yeah.
like to watch a video of cute cats, and it starts streaming you a video of cute cats that are generated by the AI based on your past watch history, the type of content that you liked in the past. And then you can even customize it, like say, oh, I want them to be playing outdoors, or I want them to be playing indoors, things like that. I mean, I definitely see that happening. I think it's just a
Yeah.
matter of having like the training data, like you're saying, which is really difficult, and then the like computational ability and like the number of GPUs to actually run these things. But I definitely see that somewhere down the future.
Yeah,
But yeah, man.
AI generated is coming without a doubt.
Yeah, yeah. All right, man. Thanks for coming on. And yeah, I'll talk to you later.
Yep. Thanks for the invite. It was
Thanks.
really
Bye-bye.
nice to talk. Take care.
Yep. Bye bye.